Hello, this is Mr. Muller for Lesson 7-3, Multiplication Properties of Exponents. Depending on what group you are in, on Friday's guided math lesson, I might have done some of these problems with you already, but I don't think I got to it with every group. Okay, so we are using multiplication properties of exponents to evaluate and simplify problems. Okay, so our basic rule for today is we're going to be multiplying numbers and adding exponents to try to simplify and or solve problems. So if I have something like 3 to the 5th times 3 to the 2nd, I really have 3 5s here, and 5 3s here and 2 3s here, which is going to give me 7 3s. So I have, instead of saying 3 to the 5th times 3 to the 2nd, I can just say 3 to the 7th. Notice how this is a multiplication problem. Tomorrow we'll be doing division, so that'll be a little different. Okay, so adding the exponents. So again, something like this, 6 to the 7th times 6 to the 4th. I have 7 6s and 4 6s, which really makes 11 6s. Something like this would be, I have a 3 as my base, that's not going to change. 2 3s here, 5 3s here is going to give me 7 3s. I can also do that when I simplify things. So I have a 2 to the 4th and a 2 to the negative 2, which if I add those is going to give me 2 to the 2, 2 to the 2nd, and a 3 to the 4th and a 3 to the 2nd, which is going to give me a 3 to the 6th. Depending on what the book says, if it says evaluate or if it says simplify, this might be your answer. You might be done, or you might have to actually solve that out. You can do the same thing with variables. It doesn't matter what it is. I have a Q3 here, and a Q6 here, so I'm going to end up with Q9. Okay, it just looks like 2 9s. Alright, and then just an r to the 2nd, nothing else I can combine it with. So there's my r to the 2nd. Here I have all n's here, n to the 3rd plus a negative n to the 4th is an n to the negative 1, and then plus 1 is going to be n to the 0, so 1. Doesn't really matter what n is there. Here I have x and an x to the negative 1, those are just going to cancel out. X to the negative 3 and x to the negative 4th is going to give me x to the negative 7th. And again, we can leave it as x to the negative 7, but it's probably a little more mathematically correct to say 1 over x to the 7th, like we learned in that first lesson. This and this are really the same thing. Okay, you might have it in problems like this, like with scientific notation, and it's pretty much the same thing, where we're going to multiply these numbers. So 1.86 times 3.6 is going to give us 6.696. 10 to the 5th power, so now it's a 10. I have 5 10s here, and then I have 3 10s here. So 5 10s and 3 10s really make 8 10s. So some of you might be saying, well, what's the difference from this to the other problem? Well, it's because of this multiplication right here. So I'm going to multiply this 1.86 times the 3.6, since I really have different groups here. Like here, I wouldn't multiply and get 9 to the 7th power. That's not the same. I have 2 groups of 3, 5 groups of 3, compared to here, where I have 5 groups of 1.86 and 3 groups of 3.6. That's not the same. I just can't lump them all together. So that's why you have to multiply them first before you multiply them together. And then kind of the same thing here, 4 to the 3rd power, and then you have the 2 exponents on the outside, which means you have 3 sets of 4. So there's my 3 4s, which really makes 6 4s. So 4 to the 6th power. So kind of like that. So 6 to the 7th power, and then with the 4th power outside those parentheses. Really, it's like you're multiplying those numbers. I kind of get confused with that sometimes, even as an adult. So I really like to write these out 6 to the 7th power 4 times. So 6 to the 7th power, 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 because then I know it's 7 plus 7 plus 7 plus 7. It's just little easier for me, so I don't get confused with all of these. So if I have 5 to the second power squared, so that's going to be 5 times 5 times 5, oops, times 5. Okay, so 25, 125, 625, and then 2 second power, second power, second power, second power. So it's going to end up being 625 to the 8th power, which I do not have a calculator in my hand, so I'm not going to figure that out. But so I'm just going to leave it as 625 to the 8th power. Kind of the same thing here. I have x to the 3rd power negative 5 times. So if I'm writing that negative 5 times, it's just going to end up being 1 over x to the 15th power. And then kind of the same thing with that times 4. So really it's going to end up being, so times x to the 4th, whoops, over 1. So I'm really going to end up having 1 over x to the 11th. Because I have 4 on top and 3 on bottom. And you'll kind of learn tomorrow that they're going to end up subtracting instead of adding. So in our multiplication problems, they add. Since this is a division problem down here, they are going to subtract. Kind of like what I said before, with where they actually figured it out with that 625 earlier, with that 5 to the 4th power. So here's 8 to the 3rd power, 512, x to the 3rd power, x to the 3rd power. Since we don't know what x is, it's just going to stay like that. And then kind of the same with these problems as well.